चले जाओ बाहर, पढ़ा दूंगा थोड़ी देर। हेलो, am I audible? हेलो, हेलो, am I audible?
Yes, yes, audible.
Hello, am I audible?
Yes, audible.
Hello, hello. Okay, so
Okay, so
guys,
guys,
uh, I am
I am
Brijesh
Brijesh
Kumar,
Kumar,
doing
doing
PhD
PhD
from
from
IIT
IIT
Bombay.
Bombay.
So
So
in this
in this
session, I am
session, I
the
am the
TA of
TA
this
of this
course.
course.
So
So
in this
in this
regard,
regard,
we
we
conduct
conduct 2 hour
uh,
uh,
interaction
interaction
meeting
meeting
on
on
each
each
Monday
Monday
at
at
from
from
7 to
7 to
9.
9.
Okay.
Okay.
So
So
in this
in this
course,
course,
mainly,
mainly,
have you
have you
seen the
seen the
videos
videos
for
for
this week?
this week?
Anyone?
Anyone?
Hello.
Hello.
Can you
Can you
respond?
respond?
Which
Which
lecture
lecture
you
you
saw?
saw?
I can
I
read
can
the
read the
chat,
chat,
but if
but if
you
you
can
can
speak, then
speak,
it
then
will
it
be
will be
more
more
Am I audible?
convincing.
convincing.
Brijesh?
Okay,
Okay,
week
week
1,
one,
lecture
lecture
1.
one.
So
So
this is
this is
about
about
review of
review of
Maxwell
next
equation, right?
equation, right?
Yes, sir.
You are
You
not
are not
audible,
audible,
any
any
of
of
you.
you.
It's my
My
mic
mic
is
is
something.
something.
You're audible, sir.
Okay.
Hello, can
Hello,
you
can you
speak
speak
now?
now?
Hello.
Yes,
Yeah,
sir.
Yeah.
now
Now
I
I
can
can
hear.
hear.
So
So
in this
in this
first
first
week
week
lecture,
lecture,
you
you
have
have
the
the
video on
video on
topic
topic
of
of
review of
review of
Maxwell
Maxwell
equations,
equations,
wave
wave
equation,
equation.
first
First,
sorry.
sorry.
So
So
first
first
video is
video is
about
about
Maxwell
Maxwell
equation.
equation.
Second
Second
one
one
is
is
wave
wave
equation.
equation.
Third
Third
one
one
is
is
for
for
dispersion
dispersion
relation.
relation.
Can you
Can
see
you see
the
the
screen
screen
which I
which
am
I am
writing?
writing?
Yes.
Okay,
Okay,
okay.
okay.
And the
And the
fourth
fourth
video
video
is
is
about
about
propagating
propagating
and
and
evanescent
evanescent
waves.
waves.
Okay.
Okay.
Uh, propagating
Propagating
waves
waves
and
and
evanescent
evanescent
waves.
wave.
And
And
fifth
fifth
one
one
was
was
diffraction
diffraction
limit.
limit.
and
and
sixth
sixth
one
one
is
is
plane
plane
wave.
wave.
So
So
this
this
is
is
about
about
this
this
week
week
lectures.
lectures.
Okay.
Okay.
So in
So
this
in this
introduction
interaction
session,
session,
what
what
I will
I
try
will
to
try to
cover
cover
that
that
all
all
the
the
topics which
topics
will
which
be
will be
covered in
covered
the
in the
last
last
week.
week.
I
I
will
will
summarize
summarize
these
these
one,
one,
or
or
sometimes if
sometimes
you
if you
ask some
ask some
question, I
question,
can
I can
give the
give the
answer
answer
about that
about that
thing
thing
also.
also.
And
And
I will
I
try
will try
to
to
uh, give
give
your
your
answer in the
answer in
same
the same
lecture. If
lecture.
I
If I
not able
not
to
able
give,
to give,
then I will
then I will
carry it
carry it
to the
to the
next
next
session also.
session also.
Okay,
Okay,
is it
is
okay?
it okay?
Okay. But if
Okay,
we
sir.
want to ask you something, let's say not today, but during the core lecture when we hear, or if we try to have a question, and if we want to reach you later, how can we reach you?
You can
You
reach
can
me
reach
through
me
this
through this
interaction session.
interaction session.
And
And
other thing
other
is,
thing is,
I think
I think
in the
in the
NPTEL course
NPTEL
there is
course there
some
is
Google
some
group,
Google
right?
group, right?
Okay, okay.
Is it
Is it
is
Yeah,
there
yeah.
any
We
is
can
there
Google
any
group?
post
Google group?
query. Yeah, yeah.
Okay, okay, you
Okay,
can
okay, you
post
can
there the
post there
query.
the query.
And
And
till now I
till
am
now I
not
am not
accessible
accessible
for that,
for
but
that,
I
but
will try
I will try
to
to
connect in that
connect in that
through this
through
group,
this group,
Google group
Google
only.
group only.
Okay.
Okay.
And if you
And if you
want
want
some
some
contact number, I
contact
can
number, I
give
can
you
give
that
you that
also.
also.
Yeah, sir. Please share.
Okay,
Okay,
so you
so
can
you
You can
can
yeah.
980
980
double eight
double eight
double
five
six
double
five
six
one.
five one.
So if
So if you
any query
any
you
query
have,
you have,
you post
you
on this
post on this
WhatsApp
WhatsApp
message.
message.
And
Double 607
980
Nine eight
double
zero
eight
double eight
five double
five
six
double
five
six
one.
five one.
51. Okay.
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 Uh,
Okay. Thank you, sir.
so
So
if I am
if I
not
am not
free at
free
that
at
time,
that
then I
time, then I
can
can
solve it
solve
later
it
and
later
then
and then
share it
share it
solution with
solution
you
with you
also.
also.
Double eight
Double
five
eight five
double
double
six
six
five one.
five one.
Okay.
Okay.
So
So
mostly
mostly
try
try
to
to
go
go
through
through
the
the
Google group,
Google group,
but this
but
is
this
for
is for
emergency case
emergency
if I
case
am
if I
not
am
able
not
to
able
see
to
your
see your
query.
query.
Uh, and
And
this will
this
be
will be
the
the
pattern of
pattern of
this
this
interaction
interaction
session.
session.
And
And
after
after
summarizing
summarizing
these
these
topics
topics
from my
from my
side,
side,
I
I
will
will
try
try
to
to
solve some
solve some
tutorial
tutorial
questions
questions
which
which
I
I
collected
collected
from
from
previous
previous
year
year
assignments
assignments
or
or
some
some
my
my
self
self
notes
notes
where I
when I
was
was
learning.
learning.
Okay,
Okay.
so
So
I
I
come
come
to the
to the
topic
topic
first by
first by
first,
first,
one by
one by
one.
one.
So
So
first
first
is
is
Maxwell
Maxwell
equation.
equation.
So
So
have
have
you
you
read
read
Maxwell
Maxwell
equation
equation
before
before
that
that
this
this
course,
course,
or
or
you
you
just
just
saw
saw
this
this
Maxwell
Maxwell
equation
equation
in
in
this
this
course
course
only?
only?
Sir, during this course only.
Okay.
Okay.
So
So
Maxwell
Maxwell
equation
equation
one,
one,
two,
two,
three,
three,
and
and
other
other
one.
one.
What
What
about
about
other
other
one?
one?
What
What
about
about
others?
others?
So
So
have you
have you
understand
understand
what is
what is
the
the
Maxwell
Maxwell
equation?
equation?
Just went through lecture. Did not think about it deeply.
Okay.
Okay.
So
So
Maxwell
Maxwell
equation is
equations is
about
about
like we
we
have
have
read
read
electrostatics,
electrostatics,
right?
right?
In
In
this
this
one,
one,
we
we
read
read
about
about the
the static
static
charge,
charge, about static charge
effect,
effect,
and
and
then
then we go to the
electrodynamics.
electrodynamics.
Uh, Electrodynamics is
Electrodynamics is
the
the
combination
combination
of
of
this
this
electrostatics
electrostatics
and
and
magnetostatics,
magnetostatics,
and
and
magnetrodynamics
magnetrodynamics
and
and
electrodynamics.
electrodynamics.
All
All
so
so
in
in
electrostatics,
electrostatics,
very
very
first
first
we
we
read
read
about
about
Gauss law,
Gauss law,
right?
right?
Gauss
Gauss
law of
law of
electrostatics.
electrostatics.
So
So
this
this
was
was
our
our
first
first
Maxwell
Maxwell
equation.
equation.
So
So
we
we
can
can
write in
write
the
in the
differentiation
differentiation
form
form
also,
also,
and
and
in
in
integration
integration
form
form
also.
also.
All the
All the
Maxwell
Maxwell
equation
equation
can
can
have
have
two
two
forms,
forms,
either
either
differentiation
differentiation
form
form
or
or
the
the
integrating
integrating
form.
form.
Okay,
Okay,
you
you
can
can
read
read
it
it
in
in
more
more
detail
detail
in
in
some
some
specific
specific
books
books
like
like
Griffith's
Griffith's
electrodynamics.
electrodynamics.
Griffiths you
Griffiths you
can
can
read
read
about
about
the
the
detail of
detail of this
Maxwell
Maxwell
equation.
equations.
So
So
first
first
Maxwell
Maxwell
equation is
equation is
derived
derived
from the
from the
Gauss
Gauss
law.
law.
of electrostatic.
electrostatics.
Okay,
Okay,
and
and
similarly,
similarly,
the so
so
what is
what
the
is the
Gauss
Gauss
law
law
of
of
electrostatic?
electrostatic?
If
If
some
some
charge
charge is
inside
inside
some
some
volume,
volume, the
outgoing
outgoing
flux
flux
should be
should
equal
be
to
equal
the
to the
uh,
uh,
charge
charge
bounded in
bounded in
this
this
volume.
volume, right?
This is
This
the
is the
Gauss law.
Gauss law.
So you
So
can
you can
write it
write it
like
like
del dot
del dot
E is equal to
E
rho. So
equal to
rho
rho.
is
So
the
rho is the
charge
charge
density,
density,
we can
we
say.
can say.
So
So
rho by
rho by
epsilon.
epsilon, sorry.
So this is the
So
Gauss
this
law.
is the
So
Gauss
this
law. So
convert
this
to our
convert to
first
our
Maxwell
first
equation
Maxwell equation
because
because
this
this
epsilon naught goes
epsilon
to
naught
this
go
side
to this
and
side,
then
and then
uh,
uh,
epsilon naught
epsilon naught
del dot E
del dot
equal
E
to rho.
equal to rho.
So if
So if
epsilon naught is
epsilon naught is the
independent of
independent of
the
the
space
space,
because
because
epsilon is
epsilon
not
is
the
not
function
the
of
function of
x comma y
x
comma
comma
z,
y comma z,
then
then we
we can
can
say
say
this is
this is
constant.
constant. So we can
This can go
this can go
through
through
inside. So
inside.
del
So
dot
del dot
epsilon
epsilon
naught E
naught E
is equal to rho.
equal to rho.
So this
So
you can
this you
write
can
del dot
write
E
del
equal
dot
to
D is equal to
rho.
rho.
Okay.
Okay.
Mm. So Gauss
So Gauss
law,
law,
the first
this is the first
equation.
Maxwell equation.
Second Maxwell
Second
equation
Maxwell
is
equation is
again
again
Gauss
a
law of
Gauss law of
magnetostatics.
magnetostatics.
So
So
like
like
any
any
magnetic
magnetic
charge like
charge
del
like
dot
del dot
equal to
B
zero.
equal to zero.
So the
So the
significance of this
significance of
Maxwell
this
equation
Maxwell
is
equation
that
is that
the
the
monopole of
monopole of
magnet
magnet
is
is
cannot be
cannot be
exist.
exist.
Okay,
Okay,
have you got
have
this
you got this
point?
point?
The
The
monopole of
monopole of
magnet
magnet
cannot
cannot
exist
exist
because
because
the
the
magnet
magnet
has
has
one
one
south pole
south
and
pole
north
and
pole.
north pole.
So north
So
pole
north pole
corresponding to we
corresponding to,
can
we can
say
say
plus m,
plus m,
and this is
and this is
minus m.
minus m.
So
So
if
if
we
we
surround it
surround it
by
by
something,
something,
so
so
whatever
whatever
flux
flux
go
go
outside
outside
comes
comes
inside
inside
this side.
this side.
So this
So
the
this the
whole
whole
flux
flux
going
going
outside this
outside this
boundary is
boundary
zero,
is zero,
right?
right?
But if
But if
you
you
this is
this is
always
always true,
because if
because
you
if you
break this
break this
magnet from
magnet from
here,
here,
then
then
again
again if
this is
this is
north pole,
north
then
pole,
this
then this
becomes south
becomes
pole.
south pole.
Then
Then
again the
again the
flux
flux
becomes like
becomes
this.
like this.
So if
So
you
if you
boundary line
boundary line
this thing,
this thing,
then it's
then is
again the
again the
flux
flux
net flux
net flux
going
going
outside is
outside
zero.
is zero.
So
So
this law
this law
states
states
that the
that the
monopole of
monopole of
magnets
magnets
cannot
cannot
exist.
exist.
Okay,
Okay,
and this is
and this
also
is
known
also known
as
as
Gauss law
Gauss
of
law of
magnetostatics.
magnetostatics.
Similarly,
Similarly,
fourth,
fourth,
third and
third and
fourth you
fourth
can
you can
say
say
del
del
dot
dot
E
E
and
and
del
del
dot
dot
H.
H.
This
This
can
can
be
be
written as
written as
J
J
plus
plus
del
del
D
D
over
over
del
del
T,
T,
and
and
del
del
dot
dot
E
E
is
is
equal
equal
to
to
minus
minus
del
del
V
V
over
over
del
del
T.
T.
So
So
this is
this
the
is the
third
third
equation
equation,
and
and
this
this
is
is
fourth
fourth
equation.
equation.
So
So
I
I
can
can
see the
see the
last
last
assignment
assignment
question
question
was
was,
first
first
question
question
was
was
that
that
match
match
the
the
following
following
Maxwell
Maxwell
equations
equations
in
in
different
different
form
form
with
with
their
their
individual
individual
names.
names.
So
So
first,
first,
as you
as you
can
can
say,
say,
del
del
dot
dot
D
D is
equal
equal
to
to
rho.
rho.
Second one
Second
is
one is
del
del
dot
dot
V
V
equal
equal
to
to
zero.
0.
Third
Third
one
one
is
is
del
del
cross
cross
E
E
equal to
equal to
minus
minus
del
del
V
V
over
over
del
del
T.
T.
And
And
fourth one
fourth
is
one is
del
del,
sorry
sorry,
del
del
dot
dot
H
H
equal
equal
to
to
J
J
plus
plus
del
del
D
D
over
over
del
del
T.
T.
So
So
at
at
this
this
side
side,
there
there
is
is
the
the
name
name
is
is
written
written
here
here
like
like
Faraday
Faraday
law.
law.
V is
Is
Gauss
Gauss
law of
law of
electrostatic.
electrostatic.
C is
Is
Ampere's
Ampere's
Maxwell
Maxwell
law,
law.
and
And
fourth
fourth
is
is
Gauss
Gauss
law of
law of
magnetostatics.
magnetostatics.
So
So
what will
what
be
will
the
be the
first
first
match?
match?
Can you
Can you
tell
tell?
anyone?
Anyone?
Sir, 4 will match with D.
4
4
will
will
match
match
with
with
D.
D.
No.
No.
This is
This is
Gauss law
Gauss
of
law of
magnetostatics.
magnetostatics.
So
So
Gauss law
Gauss
is
law is
about
about
that.
Oh, sorry, sorry, 2, 2, 2.
yeah.
Gauss law is
Gauss law
always
is always
combined with this
combined with this
divergence.
divergence.
So B
So
is
these
divergence. One is
divergence one is
both are
both
Gauss
are
law.
Gauss law.
And if it
And
is
if it
B,
is
then
B,
it is
then
Gauss
it
law
is
of
Gauss law of
magnetostatics. If
magnetostatics.
it is
If
B
it
or
is B
E,
or
then
E,
this
then
is
this
Gauss
is
law of
Gauss law of
electrostatics.
electrostatics.
B will match with 1. Huh.
Yeah,
Yeah.
one is
One
B.
is B.
And
And
what about
what
third and
about
fourth?
third and fourth?
Third will match with Faraday's law.
Yes,
Yes,
Faraday's law.
Faraday's law.
And fourth
And
one
fourth
will
one
be
will be
Ampere's law.
Ampere's law.
Ampere's law.
So any
So
doubt
any
in this
doubt
one
in this
that
one that
how we
how
can
we
get
can
this
get this
J in
J
this
in
term
this
diver
term diver
whatever
over
H
diverage
whatever D
diver D
whatever
over
T.
diver T.
But
But
here
here
there is
there
only
is only
no term is
no term
added,
is
right?
added, right?
So
So
that's why it
that's
is
why it
called
is called
Ampere's
Ampere's
Maxwell law,
Maxwell
because
law, because
Ampere's law
Ampere's
was
law was
initially was
initially was
just
just
diver over
diver over
diver
diver
cross
cross
diver B
diver
equal
B
to
equal
diver
to diver
E over
E
diver
over
T.
diver T.
But
But
the
the
Maxwell
Maxwell
cracked
cracked
this, and
this,
this
and this
J
J
comes
comes
after
after
the
the
correction of
correction of
Maxwell.
Maxwell.
Okay,
Okay,
and this
and this
J
J
is
is
known as
known as
uh,
uh,
free current,
free current,
surface current
surface current
on the
on the
volume.
volume.
And
And
how this
how this
comes
comes
from,
from,
this J
this
term,
J
how
term,
it
how it
comes.
come.
So
So
from
from
first law
first
we
law
can
we
see
can see
diver over
diver over
diver
diver
T
T
is equal to
equal to
rho upon
rho upon
epsilon naught.
epsilon naught.
Okay,
Okay,
so
so
again you
again
can
you
write
can write
diver dot
diver dot
epsilon naught
epsilon naught
is equal to
equal
rho.
to rho.
So if
So if
we
we
find the
find the
time
time
derivative of
derivative of
E
E
vector,
vector,
then
then
how can
how
you
can you
say?
say
We
we
differentiate this
differentiate this
equation,
equation,
and then
and
you
then
will
you will
get
get
diver
diver
dot
dot
epsilon is
epsilon is
constant
constant
in
in
terms of
terms of
T,
T,
then
then
diver
diver
E
E
over
over
diver
diver
T
T
is equal to
equal to
diver
diver
rho
rho
over
over
diver
diver
T.
T.
Okay,
Okay,
so
so
it
it
comes from
comes from
diver
diver
rho over
rho over
diver
diver
T.
T.
Then
Then
this is
this is
you know
you
the
know the
continuity
continuity
equation.
equation.
The
The
continuity
continuity
equation
equation
says that
says that the
current
current
is
is
equal to
equal
the
to the
rate of
rate
change
of
of
change of
charge,
charge,
right?
right?
So
So
this
this
I
I
can be
can be
written
written
in the
in the in
surface.
surface.
You can
You
write
can write
J is
J
the
is the
surface
surface
current,
current,
I is
I
the
is the
current,
current,
okay?
okay?
But J
But
is the
J is the
surface
surface
current, and
current,
if
and if
you
you
uh,
uh,
integrate it
integrate it
surrounding this
surrounding this
surface,
surface,
then
then
it
it
will
will
be
be
equal
equal
to
to
minus
minus
diver over
diver over
diver
diver
T,
T,
and
and
this
this
Q
Q
can be
can be
written
written
as
as
integration of
integration of
rho
rho
dV,
dV,
right?
right?
This
This
Q is
Q is
written as
written as a
rho
rho
dV.
dV.
Then
Then
you
you
can
can
say
say
this
this
from
from
the
the
Stokes
Stokes
law.
law.
You
You
can
can
say
say
diver
diver
dot
dot
J,
J,
then it
then it
converts to
converts
the
to the
volume
volume
integral,
integral,
right?
right?
So
So
this
this
will
will
be
be
minus
minus
diver
diver
rho
rho
over
over
diver
diver
T
T
into
into
dV.
dV.
From
From
here you
here
can
you can
write
write
diver
diver
dot
dot
J
J
is
is
equal
equal
to
to
diver rho
diver rho
over
over
diver
diver
T,
T,
right?
right?
Then
Then
from
from
here,
here,
if you
if you
go
go
in
in
this
this
equation,
equation,
you can
you can
write
write
diver
diver
over
over
diver
diver
dot
dot
J.
J.
So
So
diver
diver
dot
dot
epsilon
epsilon
diver
diver
E
E
over
over
diver
diver
T
T
is
is
equal
equal
to
to
minus
minus
del
del
dot
dot
J.
J.
So
So if we
if
if
it
it
comes to
comes to
this
this
side,
side,
then it
then it
will
will
go
go
diver
diver
dot
dot
epsilon
epsilon
naught
naught
diver
diver
E
E
over
over
diver
diver
T
T
minus
minus
plus
plus
J
J
equal
equal
to
to
0.
0.
This
This
equation
equation
satisfies
satisfies
to
to
this
this
one.
one.
From
From
first,
first,
if you
if you
say
say
the
the
Ampere's law
Ampere's
is
law is
like
like the
current,
current,
if
if
it is
it
a
is a
line,
line,
and
and
one
one
current
current
is
is
going
going
inside
inside
like
like
I.
I.
You
You
understand?
understand?
Yes, sir.
Hmm.
Hmm.
So
So
that so
so
here
here
you can
you can
write,
write,
see,
see,
J
J
is,
is
we
we
first we
first we
consider
consider
only
only
surface
surface
current,
current, free
surface current.
surface current.
But
But
from the
from
this
this
equation you
equation
can
you can
say this
say this
J
J
dash is equal
dash is
to
equal to
epsilon naught
epsilon naught
diver
diver
over
E
diver
over
t
diver
plus
T
J,
plus J,
because
because this
this is
this
del
is
dot
del
J is
dot
equal
J
to
is
0.
equal to
If
0.
there is
If there
no
is no
current,
current,
the
the
constant current,
constant current,
then you can
then
say
you
this
can say
del
this
dot J
del
equal
dot
to
J
0.
equal to 0.
Okay,
Okay,
so now
so now
surface current
surface
is
current
not
is not
only J,
only
this
J,
is
this
J
is
dash.
J dash.
So
So
this J
this
dash
J dash
will comes
will comes
to the
to the
equation
equation
del
del
dot
dot
V
V
is equal
is
to
equal
mu
to
naught
mu naught
and
and
J
J
plus
plus
epsilon naught
epsilon naught
divided E
diver E
over divided
over
T.
diver T.
So you
So
can
you
write
can
this
write this
epsilon naught
epsilon
into
naught
E
into
is
E
equal to
is equal
divided
to
D over
diver D
divided
over
T.
diver T.
So this is
So
the
this is the
modification of
modification of
Ampere's law by
Ampere's law by
Maxwell and
Maxwell and
converts into the
converts into the
this
this
third
third
fourth Maxwell
fourth
equation.
Maxwell equation.
Okay,
Okay,
and
and
if
if
you
you
want to know
want
the
to know the
integral
integral
form,
form,
so I
so I
can
can
just brief
just
you.
brief you.
Like
Like
first
first
you write
you
diver
write
over
diver over
diver dot
diver
E
dot E
is equal to
is
rho
equal to
upon
rho upon
epsilon naught,
epsilon
right?
naught, right?
But
But
in the
in the
integral form
integral
you can
form you
write
can write
the
the
closed
closed
surface
surface
integral
integral
ds is
ds
equal
is
to
equal to
q upon
q upon
epsilon.
epsilon.
Okay,
Okay,
this is
this is
integral form
integral form
of Maxwell
of
equation.
Maxwell
This is
equation. This is
differential form
differential form of
of Maxwell equation.
Maxwell equation.
Okay, you can
Okay, you
write
can
in
write
both
in
ways.
both way.
And
And
second one is
second one
del
is
dot
del dot
g equal
g
to
equal
0.
to 0.
This is the
This is the
differential form.
differential form.
What is
What
the
is the
integral
integral
form?
form?
Like
Like
Gauss law,
Gauss
what
law, what
states
states
that
that
this is the
this is the
surface of
surface
any
of any
volume.
volume.
Okay,
Okay,
so
so
the
the
flux
flux
going
going
outside
outside
from
from
this
this
volume,
volume,
if
if
this
this
surface is
surface is
zero,
zero,
right?
right?
So if
So if
we
we
have
have
some
some
b
b
vector
vector
in the
in the
very
very
small
small
region,
region,
ds
ds
region,
region,
then
then
this
this
is
is
the
the
flux.
flux.
Okay,
Okay,
if this
if
is the
this is the
flux and
flux,
if
if
we
we
integrate
integrate
to the
to
whole
the whole
surface,
surface,
then this
then
is the
this is the
total
total
flux going
flux going
outside this
outside this
surface,
surface,
right?
right?
So
So
this will
this will
go to
go
zero.
to zero.
So this
So this
converts, this
converts,
is
this is
differential form,
differential form,
and this
and this
converts
converts
the
the
integral form
integral
of
form of
Maxwell
Maxwell
equation,
equation,
right?
right?
Similarly,
Similarly,
you
you
can
can
write
write
del
del
cross
cross
E
E
equal to
equal to
minus
minus
diver
diver
V
V
over
over
diver
diver
T.
T.
So
So
similarly,
similarly, if
if you
you
want to
want
write
to write
in the
in the
integral
integral
form,
form,
so
so
what
what
Ampere's law
Ampere's law
told,
told,
like
like
uh,
uh,
if
if
this is
this
the
is the
any
any
closed
closed
uh,
uh,
contour,
contour,
so
so
this
this
is
is
the
the
small
small
region
region
DL,
DL,
right?
right?
If
If
this is
this
the
is the
current
current
element
element
inside
inside
this
this
bond,
bond,
like
like
element,
element,
then
then
electric
electric
field
field
here
here
due
due
to
to
this
this
DL
DL
is
is
E
E
vector
vector
dot
dot
DL
DL
vector.
vector.
If we
If we
integrate
integrate
to the
to the
whole
whole
contour,
contour,
then
then
it
it
should
should
be
be
equal
equal
to
to
diver
diver
over
over
diver
diver
T,
T,
change
change
of
of
flux
flux
of
of
magnetic
magnetic
field,
field,
right?
right?
This is
This is
the
the
Faraday
Faraday
law,
law,
right?
right?
So
So
you
you
can
can
write
write
magnetic
magnetic
flux
flux
B
B
dot
dot
ds.
ds.
Okay,
Okay.
so
So
any
any
change in
change in
electric
electric
field
field
due
due
to
to the,
in
in
this
this
region
region
will be
will be
the
the
time
time
change
change
in
in
the
the
magnetic
magnetic
flux.
flux.
If
If
magnetic
magnetic
flux
flux
change,
change,
electric
electric
field
field
will
will
generate,
generate,
right?
right?
If
If
electric
electric
field
field
electric
electric
field
field
change in
change
the
in the
time,
time,
then
then
magnetic
magnetic
field can
field
be
can be
produced.
produced.
This is
This
the
is the
Faraday law,
Faraday law,
two
two
law,
law,
right?
right?
So
So
this
this
can be
can be
converted in
converted in
this
this
form,
form,
and this
and
is
this
known
is
as
known as
third
third
Maxwell
Maxwell
equation.
equation.
Similarly, in
Similarly, in
fourth,
fourth,
you
you
can
can
in
in
differential
differential
form,
form
you
you
write
write
diver
diver
over
over
diver
diver
V
V
is
is
equal
equal
to
to
mu
mu
naught
naught
J
J
plus
plus
epsilon
epsilon
naught
naught
diver
diver
E
E
vector
vector
over
over
diver
diver
T,
T,
right?
right?
Similarly, if
Similarly,
you
if you
want to
want to
write in
write in
the
the
uh,
uh,
integration
integration
form,
form,
you
you
can
can
write
write
that
that
the
the
magnetic
magnetic
flux
flux in
In
this
this
season
season
will
will
be
be
DL
DL
equal
equal
to
to
mu
mu
naught
naught
the
the
current
current
in
in
this
this
one
one
I
I
naught
naught plus
plus
epsilon
epsilon
naught
naught
and
and
change
change
in
in
electric
electric
into TS.
TS.
So
So
this will
this
be
will
the
be the
this is
this is
just
just to
give you
give
some
you some
view.
view.
Otherwise,
Otherwise, the
mostly
more
more
people
people talked
talked
about the
about the
differential
differential
form of
form of
maxwell
Maxwell
equation.
equation.
What
What
you can
you
write
can
in
write
the
in the
integration form
integration
if
form
you
if you
want to
want to
solve
solve
some
some
problems.
problems.
Okay,
Okay,
in the
in the
um,
some um,
exams,
exams,
comes
comes
from the
from
in
the
this
in
form
this form
only.
only.
So
So
after this
after this
Maxwell
Maxwell
equation
equation
review,
review,
you go to
you
the
go to
wave
the wave
equation.
equation.
So you
So
know
you know the
what
what
is
is
the
the
simple wave
simple wave
equation
equation
in the
in the
sound wave
sound
or
wave
something.
or something.
Can you write?
Can you write?
Hello.
Hello.
See, if
See,
this
if
is the
this is
phi
the phi
x
x
any wave
any wave
function, right?
function, right?
I am
I
not
am
talking
not
about
talking about the
the EM wave,
EM wave,
just a
just
wave.
a wave.
So
So
if
if
you
you
know that
know that in the
sound wave,
sound waves,
uh, the wave
the wave
equation
equation
connect
connect the
second
second
derivative of
derivative of
this
this
spatial
spatial
develop
develop
square
square
whatever
whatever
x
x
square
square
psi
psi
is equal to
is equal
1
to
upon
1
v
upon v
square
square
develop
develop
square
square
over
psi
develop
over develop
t
t
square.
square.
So here
So
this is
here
the
this is the
function of
function of
derivative of
derivative
time,
of time,
and this is
and
the
this is the
derivative of
derivative of
x,
x,
and this
and this
connects with
connects
the
with the
velocity of
velocity of
this wave,
this wave,
right?
right?
Similarly,
Similarly, in
if you
if you
write,
write,
you can
you
see in
can
the
see in the
video
video
also.
also.
Uh,
Uh,
if you
if you
connect in
connect
this,
in these two in
these
these
four
four
uh, Maxwell
Maxwell
equation,
equation,
you will
you will
get
get
the
the
in the
the
form of
form of
Dever
dever
square
square
dever
dever
e
e
over dever
over dever
x
x
square
square
is
is
equal to
equal to
very
very
simplest form.
simplest form.
If you
If
get
you get
uh,
uh,
around
around
mu
mu
naught
naught
epsilon naught
epsilon naught
dever
dever
square
square
e
e
over
over
dever
dever
t
t
square.
square.
You can
You
also
can
write
also write
e
E
vector
vector
replaced with
replaced with
h vector.
H vector.
So
So
in the
in the
wave,
wave,
if
if
you go
you
to the
go to the
sound waves
sound
and
waves and
other waves,
other waves,
this is the
this is the
scalar
scalar
function. But
function. But
here this
here
is
this
the
is the
vector vector form
vector
of
form
this
of this
equation. This is
equation.
the
This is the
difference between
difference
the
between the
sound waves
sound
and
waves and
EM
EM
waves
waves
also.
also.
So if
So if
you
you
compare
compare
these
these
equation to
equation
this
to this
equation,
equation,
then you
then
will
you will
find that
find
the
that the
wave of
wave of
EM wave,
EM wave,
velocity of
velocity of
EM wave,
EM
you
wave,
can
you can
write
write
v
v
square is
square
equal
is equal
to
to
1
1
upon mu
upon mu
naught.
naught.
Sorry.
Sorry,
If you
if
write
you
mu
write
naught
mu
and
naught and
epsilon naught,
epsilon naught,
then
then this is the
uh,
uh,
parameter of
parameter of
vacuum. Okay,
vacuum. Okay,
in
in
vacuum,
vacuum,
EM wave
EM wave
travel
travel
with the
with the
velocity of
velocity of
light.
light.
So
So
this will
this will
convert into
convert
C.
into C.
If
If
this is
this
the
is the
parameter
parameter
of
of
material
material
like
like
epsilon
epsilon
and
and
mu,
mu,
then you
then
can
you can
write
write
velocity
velocity
of
of
EM
EM
wave
wave
in
in
that
that
material
material.
uh,
Uh,
um, V
V
square is
square is equal
equal
to
to
mu
epsilon.
epsilon.
Okay,
Okay,
so you
so
can
you can
write
write
V is
V is
equal
equal
to
to
1
1
upon
upon
root
root
mu
mu
epsilon.
epsilon.
And
And
if
if
you
you
talk
talk
about
about
the
the
vacuum,
vacuum,
then
then
C
C
will
will
be
be
1
1
upon
upon
mu
mu
naught
naught
epsilon
epsilon
naught
naught
root.
root.
Got it?
Got it?
This is
This is
just
just
the
the
addressing
address
of
of
some
some
formula.
formula.
Maybe I
Maybe I will
show
show
you
you
some
some
example
example
of
on
this
these
formula
formula
from the
from the
previous
previous
assignment.
assignment also.
So
So
in
in
this
this
way,
way,
you
you
can
can
calculate
calculate
the
the
velocity of
velocity of
EM
EM
wave.
wave.
Okay,
Okay,
and
and
if
if
you
you
solve
solve
this
this
equation
equation
for
for
like
like
plane
plane
wave,
wave,
then
then
this
this
solution
solution
is
is
comes in
comes
the
in the
form
form
of
of
E.
E.
Like
Like
if you
if you
want
want
to
to
E
E
vector,
vector,
then it
then it
will
will
go
go
like
like
E
E
naught
naught
cos
cos
or
or
sine
sine
kx
kx
minus
minus
omega
omega
t.
t.
Okay,
Okay,
so
so
this
this
is
is
the
the
general
general
form
form
of
of
any
any
wave
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 form.
form.
Okay,
Okay,
so
so
this will
this
be
will be
our
our
amplitude.
amplitude.
This is
This
the
is the
wave
wave
number.
number.
Okay,
Okay,
this is
this is
the
the
propagation
propagation
direction.
direction.
Like
Like
x is
x
the
is the
wave
wave
go
go
to
to
the
the
x
x
direction.
direction.
Okay,
Okay,
and
and
this
this
time
time
term
term
comes,
comes,
and
and
in
in
multiplication
multiplication
of
of
this, this is
this is
the
the
frequency
frequency
comes
come
frequency
frequency
term.
term.
Okay,
Okay,
Uh,
Uh,
you
you
got it
got it
or
or
any
any
doubt
doubt
till
till
now?
now?
Hello.
Hello.
Need to revise.
Okay, you can
Okay,
see
you
in
can
the
see in
video.
the video. So
Mm,
mm,
maybe you can
maybe you
ask
can ask
later if
later if
you
you
don't
don't
understand
understand
anything
anything
once you
once
have
you have
seen the
seen the
video.
video.
So this
So
is the
this is the
general
general
form of
form of
like
like
wave.
wave.
When you
When you
solve this
solve this
equation,
equation,
when you
when you
solve this
solve this
equation
equation
solution,
solution,
then we
then
got
we
the
got
E
the
in the
E in
form
the
of
form
this.
of
This
this.
is
This
known
is
as
known as
plane wave.
plane wave.
Okay.
Okay.
Uh,
Uh,
and
and
then
then
next
next
comes
comes
the
to the
dispersion
dispersion
relation.
relation.
So
So
dispersion
dispersion
relation is
relation is
about
about
the
the
relation between
relation
like
between like
energy
energy
and
and
momentum.
momentum.
So you
So you
know
know
uh,
uh,
the
the
de
de
Broglie wave
Broglie wave
concept.
concept.
What is
What
the
is the
uh, photon?
photon?
You know
You know
photon?
photon?
So
So
photon is
photon is
like
like
the
the
quanta of
quanta of
energy,
energy,
right?
right?
So
So
EM wave,
EM wave,
see,
see,
EM wave
EM wave
that is
that
called
is called
electromagnetic wave.
electromagnetic wave.
It is
It is
can
can
work as
work
a
as a
wave
wave
or
or
can
can
work as a
work as a
particle.
particle.
That is
That
called
is
dual
called
nature
dual
of
nature
light.
of light.
You
You
heard about
heard
this?
about this?
Yeah.
Yeah.
So
So
in this
in this
dual
dual
nature,
nature,
the
the
if
if
you
you
go to
go
the
to the
waveform,
waveform,
then we
then we
talk
talk
about
about
wavelength.
wavelength.
Okay.
Okay.
And if you
And if
go
you
about go
go
to the
to the
particle nature
particle
of
nature of
light,
light,
talk about
talk about
particle nature
particle
of
nature
light,
of light,
then
then
you
you
talk
talk
about
about
momentum,
momentum,
right?
right?
So
So
de
de
Broglie
Broglie
is
is
first
first
person
person
who
who
uh,
uh,
stabilize the
stabilize the
relation
relation
between
between
momentum
momentum
and the
and the
wavelength.
wavelength.
So
So
it can
it
be
can be
converted
converted
easily
easily
E is
E
equal
is
to
equal to
h by
h by
lambda.
lambda.
Okay,
Okay.
you saw
You
this
saw this
equation
equation
before?
before?
Any one
Any
of
one
you?
of you?
Okay.
Okay.
So
So this
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 connects
connects
the
the
wavelength
wavelength
and as
and
well
as
as
well as
p.
p.
And
And
similarly,
similarly,
if
if
you
you
talk
talk
about
about
Einstein's
Einstein's
very
very
first,
first,
the
the
Einstein
Einstein
told
told
about the
about the
that
that
photon
photon
concept.
concept.
That is the
That is the
quantization of
quantization of
wave.
wave.
So
So
he
he
told that
told that
photon
photon
is the
is the
quanta of
quanta of
energy.
energy.
So
So
if
if
it is the
it is the
quanta of
quanta of
energy,
energy,
then it
then it
uh,
uh,
takes
takes the
the small
small
bundle of
bundle of
energy
energy
and
and
travel.
travel.
Okay.
Okay.
So
So
what is
what
the
is the
energy?
energy?
This is
This is
equal
equal
to
to
h
h
mu.
mu.
We can
We can
convert it
convert it
to
to
hc
hc
upon
upon
lambda.
lambda.
You
You
must
must
seen it
seen
in
it
your
in your
12th
12th
exam,
exam,
maybe,
maybe,
right?
right?
So if
So
you
if you
have
have
one
one
energy
energy
like
like
1.98 or
1.98 or
something,
something,
and
and
what will
what
be
will
the
be the
corresponding
corresponding
wavelength
wavelength
if you
if you
talk
talk
about
about
in the
in the
wavelength
wavelength
form?
form?
Then you
Then you
can
can
convert
convert
with
with
this
this
relation.
relation.
Okay,
Okay,
so
so
this
this
is
is
important
important
relation.
relation.
You can
Can
uh, so
so
because
because
this is
this
the
is the
starting of
starting of
quantization of
quantization of
light.
light.
So
So
this is
this is
the
the
so
so
this is
this is
one
one
thing
thing
you
you
can
can
remember.
remember.
Mm,
Mm,
and
and
similarly,
similarly,
diffraction
diffraction
limit
limit
and
and
spatial
spatial
frequency
frequency
and
and
plane
plane
waves.
waves.
You
You
can
can
see in
see
the
in the
video,
video,
then you
then
can
you can
ask
ask
me the
me the
question
question
uh, later.
later.
So
So
I
I
will
will
come to
come
the
to the
previous year
previous year
assignment
assignment
question
question
one by
one by
one.
one.
Okay.
Okay.
So
So
actually,
actually,
you
you
know
know
the
the
what is
what is
the
the
like
like
we
we
talk
talk
about
about
electromagnetic
electromagnetic
radiation
radiation
or
or
electromagnetic
electromagnetic
light.
light.
Okay.
Okay.
So
So
what is
what
the
is the
part
part
of
of
this
this
electromagnetic
electromagnetic
radiation?
radiation?
We
We
can
can
divide
divide
EM
EM
radiation,
radiation is
uh,
gamma.
gamma
Gamma
radiation
radiation is
also
also
comes
comes
to the
into the
EM
EM
radiation,
radiation,
right?
right?
Similarly,
Similarly,
visible
visible Visible light is also EM part of EM radiation. Okay. And similarly, infrared, yeah, ultraviolet. You heard these names, right? So, what is the range? Do you know about range? Okay. So, visual range is about, if you talk about in wavelength, uh, we take the example wavelength. So, approximately this is go from 400 nanometer to 800 nanometer. Will you remember later this visual range? This is approximately. Some people write 450 nanometer to 750 nanometer, or some people write little bit different from this scene, but this is average. So this 800 nanometer will cover our red region. Okay, red light. So red light, sorry, 800 is little bit far. If you see the red light laser, it is 632, right? So mostly people talk about 750 till 750 in the visible range. So 632 is the red laser. And similarly, what is the green laser wavelength? You know,
Green
532.
laser.
Green laser. 532
532.
nanometer. Yeah. So this is green. This is red. So yellow will come in between this, around 600 nanometer. Okay. Yeah, 580, you can say 580 around. And similarly, 400 nanometer. This comes. This color is around blue. Okay. So up now, if you go beyond this red light, what we will say infrared. Okay. And if you go below the wavelength of blue, then you call ultraviolet. Okay. So this is region of infrared, ultraviolet. This is region of visual. So if you ask one question, what will be the range of visible light in terms of uh, energy? Can you solve it? Okay, convert this wavelength into the energy and post the answer in the chat box if you cannot say. Can you do it?
E equal to hc by lambda we have to use, right?
Yeah.
So Planck's constant into speed of light by 400 nanometer, correct?
Yeah. I can tell you one simplest number if you saw, because these are constant, right? So you can put the value of this one, these two, and multiply. And remember, all time if you convert, this comes around 1240. Not I can exact, but 1240 upon lambda, and E is equal to. And always remember, in this form, lambda always should be in nanometer, or E should be in electron volt. Okay. Now you can calculate. And if you want this lambda in micron, then you can convert it 1.24 upon lambda in micron. Please remember this short forms, because each time you will not calculate H and multiply by C like that. So this will be helpful for this region. Okay. Now can you calculate?
4.96.
4.96.
96.
Okay. And what is the corresponding this 750.
0.14 something.
0.14. This
Two
seven
po-
fifty
two 2.65.
2.65. 2.65. Okay.
So
So
now
now
I'm
I'm
writing
writing
the
the
options
options
from the
from the
last
last
assignment.
assignment.
Like
Like
there is
there
one
is one
option is
option is
around
around
200 to
200 to
400
400
nanometer,
nanometer
or
or
3.1 to
3.1 to
6.2
6.2
electron volt.
electron volt.
Okay,
Okay.
this is
This
one
is one
option.
option.
Second
Second
option is
option is
300
300
mic
mic
to
to
700
700
nanometer,
nanometer
or
or
1.8
1.8
eV
eV
to
to
4.1
4.1
eV.
eV.
Similarly,
Similarly,
third
third
option is
option is
1000
1000
nanometer
nanometer
to
to
1500
1500
nanometer,
nanometer
or
or
0.8
0.8
eV
eV
to
to
1.24
1.24
eV.
eV.
And
And
fourth
fourth
option
option
was
was
800
800
to
to
1200
1200
nanometer,
nanometer
or
or
1 to
1 to
1.55
1.55
eV.
eV.
So
So
as I
as I
said
said
that
that
different
different
people are
people are
tell
tell
about
about
different range.
different range.
Like
Like
I told
I
about
told about
400 to
400 to
800.
800.
Here is the
Here is the
nearest
nearest
300 to
300 to
700
700
nanometer.
nanometer.
Okay,
Okay.
you
You
can
can
also
also
idea about
idea
that,
about that
like
like
red
red
laser
laser
is
is
about
about
632.
632.
Okay,
Okay.
and
And
if
if
you
you
said
said
blip
blip
your,
your,
so
so
R is
R
the
is the
last one,
last one,
red.
red.
So
So
nearest
nearest
632
632
will be the
will be
upper
the upper
limit,
limit,
and
and
violet
violet
is
violet is
around
around
400
400
nanometer.
nanometer.
Okay, so
Okay. So
nearest in the
nearest in the
option you can
option you can
tick
tick
second one.
second one.
What can you
What can you
convert it
convert it
here to
here
here
to
and
here
here
and
to
here
here
to
now
here now
easily?
easily?
No, but if I put 300 nanometer,
Hmm.
Hmm.
then I am getting 6.6.
6 point.
6.6.
How?
How?
Okay,
1.4.
1.24.
Sorry,
Sorry,
1240
1240
divided by
divided by
300.
300.
This
This
zero,
0,
10,
10,
3 4
3
ja
4 ja
12.
12.
Okay,
Okay.
and this
And
is
this is
3 1
3 ones. 3 goes
4
0. 3 1.
4.13.
4.13.
Okay,
Okay.
similarly from
Similarly, from 7, if you got
1240
1240
upon
upon
700
700,
10,
10,
7
7
manja
manja
7,
7,
this is
this is
5,
5,
and
and
7 7
7 7 ja
49,
49, right?
and
And
this is
this
54.
is 54. So
1.7 is around
1.7 around
7 8.
7 8.
So you can take
So
around
you can take around
1.8, right?
1.8, right?
Okay, okay.
Got it?
Got it?
Yes.
Yeah.
Yeah.
So
So
third one
third
is
one is
which of
which
the
of the
following
following
statements are
statements are
true?
true?
Just
Just
use your common sense.
use your
That
common
the
sense
refractive index of
that
an
the refractive
absorbing
index
material
of
is
an absorbing
complex.
material is complex.
Is it true?
Is it true?
Or I can give
Or
you
I can
some
give you some
little bit explanation
little bit
from
explanation from
the
the
chapters.
chapters.
Like
Like
in the
in
optics
the
or
optics or
in
in
photonics,
photonics,
I want to
I
just
want to just
focus on that.
focus on that.
You read
You
about
read about
electronics,
electronics,
right?
right?
You
You
heard
heard
about
about
photonics.
photonics.
What is
What
the
is the
main
main
difference
difference
between
between
electronics and
electronics and
photonics?
photonics?
So
So
see,
see,
electron.
electron
So electron
electron
comes.
comes
Elec-
elec
electronics
electronics
comes
comes
from
from
electron.
electron.
Similarly,
Similarly,
photonics
photonics
comes
comes
from
from
photon.
photon.
So
So
in
in
electronics,
electronics,
we
we
study
study
about
about
manipulation
manipulation
of
of
electrons.
electrons.
Okay,
Okay,
here
here
we
we
did
did or we place them with the photon or manipulation of photon. So you know how you can manipulate electron by applying current or applying voltage, right? And
and
how
how
you
you manipulate the
manipulate the
photon.
photon? Can you
Can
think
you
about
think
that?
about that?
Pass through gratings.
Pass through
Pass through
gratings.
gratings.
So
So
what is the
what is the
grating?
grating?
See,
See,
I am
I am
just
just
ask you
ask you
question,
question,
so you
so
can
you can
think
think
about
about
that.
that.
You heard
You heard
about
about
grating, right?
grating, right?
So
So
grating is
grating is
just
just
a
a
line
line,
where
where,
we have varying refractive indices.
yeah,
yeah,
varying of
varying of
refractive index.
refractive
So
index. So
variation of
variation of
refractive index
refractive
can
index can
manipulate the
manipulate the
photon.
photon.
So
So
now
now
comes to
comes
the
to the
refractive
refractive
index.
index.
So
So
refractive
refractive
index is,
index is,
if
if
you
you
see
if you
see
see
the
the
video of
video of
this
this
dispersion
dispersion
relation
relation
or
or
wave
wave
equation,
equation,
I don't
I
remember
don't remember
exactly what
exactly
video
what
is.
video is.
You will
You will
find the
find the
relation
relation
n
n
is equal
is equal
to
to
root
root
mu
mu
epsilon.
epsilon.
Okay.
Okay.
So
So
this
this
n is
n is
comes to
comes
the
to the
dielectric
dielectric
function, from
function, from
dielectric
dielectric
function.
function.
So
So
क्या
क्या
it
it
should be
should be
complex or
complex or
not?
not?
Next
Next
question.
question.
It should
It
be
should be
complex.
complex.
It
It
may be
may be
complex
complex
or may
or may
not be
not be
complex.
complex.
So
So
mainly this
mainly this
refractive
refractive
index, if
index, if
you
you
saw in
saw in
complex form,
complex form,
I like
I
to
like to
denote it
denote it
in this
in this
form.
form.
So
So
this
this
comes like
comes like
n
n
plus
plus
I
I
into
into
k.
k.
So this
So
is the
this is the
imaginary
imaginary
part,
part
and this
and
is
this
the
is the
real part
real part
of
of
this
this
complex
complex
refractive
refractive
index.
index.
So
So
so this
so this
imaginary
imaginary
part
part
denotes
denotes
about the
about the
absorption
absorption
of the
of the
material.
material.
Okay,
Okay,
remember it.
remember it.
Can
All,
you
all
please repeat what is this n tilde?
this one.
This one,
Yes.
This is
this is
nothing but
nothing
it
but
is
it is
called
called
refractive
refractive
index, but
index, but
in
in
complex form.
complex form.
Okay. 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 Eta. Okay. Okay.
Not
Not
eta.
eta.
I
I
Okay.
I
write it
write it
n
n
only,
only,
just
Okay.
just
to
to
Okay.
differentiate from
differentiate from
this.
this.
I
I
just
just
Okay.
put.
Understood. Understood.
So this
so
is
this is
also
also
called
called
refractive
refractive
index.
index.
This is
This
the
is the
real part
real
of
part of
refractive
refractive
index
index
Okay.
or
or
gain part
gain
of the
part of the
material.
material.
Okay,
Okay,
and this
and
is
this
known
is
as
known as
absorption part.
absorption part.
So you
So
can
you can
write
write
the
the
uh,
uh,
absorption
absorption
coefficient of
coefficient of
this
this
material.
material.
Uh,
Uh,
then
then
I
I
think
think
sir has
sir has
derived
derived
this
this
in
in
dispersion
dispersion
relation, I
relation,
think.
I think.
So in
So in
that you
that
will
you will
find this
find
k
this
is
k is
related
related
directly
directly
related to the
related to the
absorption
absorption
coefficient of the
coefficient of the
material.
material.
Mhm.
Okay.
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 So
So
in the
in the
last
last
assignment,
assignment,
this was
this
the
was the
question that
question that
which of
which
the
of the
following
following
statement are
statement are
true
true
regarding the
regarding the
refractive
refractive
index.
index.
Okay.
Okay.
So
So
first
first
statement
statement
was
was
the
the
refractive
refractive
index
index
of
of
an
an
absorbing
absorbing
material
material
is
is
complex.
complex.
Is
Is
it
it
true?
true?
It
It
is
is
true.
true
Yes.
according to us
Because
because
because the
the
complex
complex
part,
part,
if
if
it is
it is
coming,
coming,
then
then
it
it
is
is
the
the
absorbing
absorbing
material
material
definitely.
definitely.
If
If
this
this
k
k
goes to
goes to
zero,
zero,
then
then
it
it
will
will
be
be
real,
real,
right?
right?
So if it
If
is
it is
complex,
complex,
then
then
it
it
is
is
absorbing
absorbing
material.
material.
Second one,
Second
the
one, the
imaginary
imaginary
part of
part
the
of the
complex
complex
refractive
refractive
index
index
determines
determines
the
the
absorption.
absorption.
This is
This is
also
also true
from
from
this.
this.
Okay.
Okay.
And the
And the
real
real
part of
part
the
of
complex
complex
refractive
refractive
index
index
determines
determines
the
the
phase
phase
velocity.
velocity.
This
This
is
is
little
little
bit
bit
advanced
advanced
statement.
statement. the real part of complex refractive index determines the phase velocity. So what is the phase velocity? Have you heard about phase velocity? So phase velocity is around v is equal to omega upon k. Am I right? And the group velocity. One is group velocity, one is phase velocity. Phase velocity we denote b, and group velocity generally we denote by bg. So this is about around taper omega over taper k. Okay. So this k is related to the refractive index n or not. Are you aware of this? This k is the wave number, right? I told you in this equation, when I write this equation. This k is the wave number. So do you know the wave number and wavelength relation?
2 pi by lambda.
Yeah, 2 pi by lambda k is equal to. So this is actually in terms of this is in vacuum only. If refractive like in vacuum there is lambda, then what will be the lambda in the material with refractive index n? Do you know? So
2 pi
this
n
is
by
equal
lambda.
to lambda by n. Okay. If you find if you write if you connect this to this, you will say k dash is equal to n into k. So if wave number is depend on n, then this phase velocity will always also depend on this. Okay. So according to all these relation, you can say the real part of complex refractive index determines the phase velocity. Do you understand?
Yes, sir.
Okay. So this was the two for 2 point. This question was in the last assignment was 2 point. Okay. Similarly, if you say actually next question is about this only. I can write so you can read it. A plane.
Sir, that previous question that is it discussed in any lecture?
No.
Okay.
And
So where can we read about it more if you want? This refractive index.
about refractive index, all these things will be covered in the lecture only.
Okay, upcoming lecture. Okay, okay.
Not upcoming. You have shown all the questions in the lecture.
No, not week one. I have not seen all. Only
Yeah,
first
yeah.
lecture I saw.
Yeah. So the first lecture is about review of Maxwell equation. So in that
Correct.
only talked about what is the Maxwell equation and what is the if the scenario change, how the Maxwell equation will
Hmm.
change. Okay. So
Okay.
this is all about this if D in the
Understood. Understood.
yeah. Okay. Same in the wave equation. If you go, then they connect the wave equation.
Hmm.
If you want me to tell, then I can just briefly tell. Like we have del dot D, del cross E, okay,
Hmm.
and del cross H, and del dot B, okay. So how we will get the this wave equation? We just take the curl of this equation, del cross E equal to what is equal to minus day over t. So you can write it del vector cross minus
dever
dever
v
v
vector
vector
over
over
dever
dever
t.
t.
So
So
if
if
this
this
is
is
thing,
thing,
then you
then
can
you can
write
write
minus
minus
dever
dever
over
over
dever
dever
t
t
del
del
cross
cross
v.
v.
We can
We can
change
change
the
the
order,
order,
right?
right?
From the
From the
vector
vector
algebra,
algebra, if you know.
and
And
from
from
this
this
equation,
equation, you know that this is
triple cross
triple
product
cross
of the
product
vector,
of the
right?
vector, right?
So you can
So you
write
can write
del dot
del dot
L
del
into
into
E
E
minus
minus
del dot
del dot E
times
times
del
del
vector, right?
vector, right?
You write
You
only
write
this
only this
type.
type.
So this
So
will be
this will
del
be del
square
square
E,
E,
okay,
okay,
minus
minus
del dot
del
E
dot
from
E from the
equation 1
equation 1
is
is
0.
0,
Okay, so
okay?
this
So
term
this
goes
term
to
goes
0,
to 0,
and in
and
the
the
last
last
you
you
write
can write
minus
minus
dever over
dever over
dever
dever
t,
t.
and
And
if
from,
you
if
say
you
this
say this
equation is
equation is
around j
around j
plus
plus
dever
dever
d over
d
dever
over
t,
dever t.
so you
So
can
you can
replace
replace
dever
dever cross b over
this
from this
equation,
equation,
right?
right?
And
And
now
now
uh, then you
then you
can
can
apply with
apply
the
with the
different
different
scenario, like
scenario, like
if you
if
have
you have
dielectric,
dielectric,
then
then
this
this
T is
t is
okay, but
okay,
J
but j
goes to
goes to
0.
0.
If
If
this is
this is
conductor, then
conductor, then
rho
this rho
del
del
these
these
parameters are
parameters are
different
different
for the
for the
different
different
material.
material.
Okay,
Okay,
then you
then
will
you
get
will get
for the
for the
simplest
simplest
form
form
this
this
dever over
dever
dever
over dever
uh,
uh,
te.
e.
So if
So if
you
you
this
this
minus
minus
dever,
dever,
sorry,
sorry,
this is
this
d.
is d.
So
So
dever
dever
square
square
dever
dever
t
t
square
square
to d,
to d,
and
and
this
this
dever
dever
square e
square e,
this one.
this one.
That's why
That's
I
why
write
I write
this
here this
equation
equation
directly
directly
here.
here.
This
This
del
del
square
square
term is
term is
related to
related to
dever square
dever
over
square
dever
over
x
dever
square
x
plus
square
dever
plus
square
dever square
over dever
over
y
dever
square
y
plus
square
dever
plus
square
dever
over
square
dever
over dever
z
z
square.
square.
So if
So
we
if
take
we
only
take only
x
x
progression in
progression
x
in x
direction, you
direction, you
will
will
choose
may
only
choose
this
only
one.
this one.
If you
If
going
you
to in
going
three
to in three
dimension, then
dimension,
you
then you
have to
have to
choose
choose
all three
all
terms
three terms
with del
with
square.
del square.
Okay.
Okay.
So this
So
is
this
all
is all
derivation has
derivation
been
has
done in
been
the
done in the
lecture,
lecture,
and
and
then
then
comes
comes
to the
to the
like
like
see
see,
we
we
till now
till
only
now
we have
only we
the
have the
statement
statement,
like
like
this is the
this is the
transverse wave.
transverse wave.
EM wave is the
EM wave is the
transfer wave.
transfer wave.
Transverse wave.
Transverse wave.
Have you heard
Have you
about
heard
this?
about this?
EM wave is
EM
the
wave is the
transverse wave.
transverse wave.
Hello.
Hello.
Heard about it, yes.
Yeah.
Yeah.
But
But if I
uh, told you
told
that
you that proof it,
this is
this is
transverse wave,
transverse wave,
then
then
how
how
will you
will you
approach?
approach?
So this
So
is
this is
the
the
small
small
things.
things,
Like
like
first you
first
have
you
to
have to
remind that
remind
what
that
is the
what is the
transverse wave.
transverse wave.
So
So
transverse wave,
transverse
if
wave, if
you
you
see
see
in
in
ninth
ninth
class
class book
textbook,
textbook,
you will
you will
easily find
easily
that
find that
transverse wave
transverse
is
wave is
like
like
vibration is
vibration is
perpendicular to the
perpendicular to the
propagation,
propagation,
right?
right?
This is the
This is the
direction of
direction of
vibration.
vibration.
Then wave
Then wave
propagate in
propagate
this
in this
direction.
direction.
Then it is
Then it
called
is called
transverse wave.
transverse wave.
And
And
other is
other is
longitudinal.
longitudinal.
So in
So in
longitudinal,
longitudinal,
vibration
vibration
direction is
direction is
also in
also
this
in this
direction
direction.
if
If
particles
particles
vibrate in
vibrate
this
in this
direction.
direction,
Okay.
okay,
And
and
wave is
wave is
also
also
traveling in
travel
this
in this
direction.
direction.
This is
This is
traveling direction.
direction.
Okay.
Okay.
So this
So
is
this
called
is called
longitudinal.
longitudinal.
So
So
now
now,
if I
if I
say
say
that
that
E
E
vector,
vector,
okay,
okay,
E
E
vector
vector
denotes
denotes
the
the
vibration
vibration
direction.
direction,
Okay.
okay,
And
and
K
K
vector
vector
denotes
denotes
the
the
propagation
propagation
direction.
direction,
Right?
right?
Are you
Are you
agree
agree
with
with
this?
this?
Okay.
Okay.
So
So
this
this, if
we
we
prove
prove
K
K
vector
vector
dot
dot
E
E
vector
vector
equal
equal
to
to
0.
0,
Okay.
okay.
So
So
what is
what
the
is the
meaning
meaning
of
of
this
this
statement?
statement?
If
If
you
you
go to
go to
the
the
vector
vector
algebra,
algebra, this k vector is perpendicular to e vector. Am I right?
Yeah, dot product is zero means they're in same plane, correct?
They are in same plane, but they are perpendicular because
Hmm.
if you say k magnitude of k into magnitude of e cos theta is equal to 0.
Hmm. Correct.
Cos theta equal to 0 means
Theta 90.
yeah, theta is 90. Because k vectors will not be 0, not neither e vector.
Hmm.
Okay,
Hmm.
then only theta is possibility equal to 0. So all these type of relation we got when we solve in this wave equation.
Hmm. Okay.
Okay, and in this one only if you uh, remember the refraction law.
Hmm.
Refraction law says that frequency will not change.
Okay.
If wave go to any medium, frequency will not change.
Hmm. Hmm.
So this will also we can prove by solving these wave equation.
Okay.
Okay, and like simply refraction is described by this Hygiene principle. Sorry, Heisenberg principle. So this is only the things of common sense type things. Like this is the wave vector. Okay, and this go to the this medium. This medium has different uh, resistance than this. So like if I say this is the our stick, okay, and here is water is flowing, and
Hmm.
we enter this stick like this angle, then what will say the water flow is higher this, then this part of go to this side. Okay, so
Hmm.
this will bend right like this. So our ray is perpendicular to this wave front. Okay, so this will bend in this medium like this, right? So wave is coming to this parallel if you say, so this will not go this side, this will go this side. So this is the simple reflection law, right? So this is the explanation on the basis of Heisenberg principle. And when we come to this electromagnetic theory, you can also prove it by solving this equation. Maybe in this wave equations, maybe sir not explain the fully solution, but you will get in the like Griffith, which my reference is only Griffith. I read the whole electromagnetic theory things from this Griffith books. You will find easily in this one also. If you only go for the wave equations and all these things. Also, many books like I can refer you. You read Ajay Ghatak Optics. In this one also one chapter about EM waves. In that one also they
Sir,
mention
we read this MN Sadiku.
Aman Sadiku. Okay. I did not heard about. Maybe.
Okay. Okay. No problem, sir. Please continue. Yeah.
Huh. So like this part I mainly read from EM. This is Ghatak book and Griffith books. Maxwell equation and the wave equation. You will find in easy uh, language. Okay. So all these things till now, you can once see the video and then we can discuss again if you want. So here was so I was in the question on you just listen and something listen you tell me. A plane wave propagation in an absorbing medium can be described by its propagation constant k is equal to n this thing and k naught. The real part of k describes the cylinder length, real part, and the imaginary part, cylinder length. So like as I said, this n naught is what? This is the complex form of refractive index. Okay, So I can say n naught plus I
uh,
uh,
k
k
naught.
naught.
Sorry,
Sorry,
I,
I
you can
can
say
say it
k
k
into k
into
naught.
k naught.
Okay,
Okay,
so this
so
will
this
be
will be
n naught
n
k
naught
naught
k naught
plus
plus
I
I
k into
k
k naught.
into k naught.
K
So
is the
k is the
imaginary part of
imaginary part of
refractive index
refractive
only.
index only.
K naught
K
is the
naught is the
wave vector.
wave vector.
Okay,
Okay,
this is the
this is
difference
the
between
difference
k and
between
k
k
naught
and k
here.
naught here.
So
So
what
what
is this
is this
quantity and
quantity
what is
and
this
what is this
quantity?
quantity?
Can you have some
Can you have
idea?
some idea?
This wave vector is different than wave number.
No, this is
No,
same.
this is same.
See,
See,
wave
wave
number is
number is the
uh,
uh,
as we say
as we
wave
say
number.
wave number.
So this is
So
as a
this is as a
scalar,
scalar,
and wave
and
vector
wave
is a
vector
form
is a
of
form
vector.
of vector. So
In this
in this wave
vector,
vector,
some
some
direction is
direction is
also
also
defined.
defined. Then
Then
the
the
wave.
Imagine
sorry,
the
Sorry.
imaginary part. I think it is the propagation constant. Is it?
this is
This is
propagation
propagation
constant.
constant or this is?
I mean, the other one with I K cannot.
Okay,
Okay,
Is it a
so
propagation?
for
for
clarification,
clarification, I
would like
would
to
like
change
to
it
change it
to
to
beta.
beta.
Hmm.
So do
So
not
do not
confuse.
confuse.
See,
See,
uh,
uh,
I
I
already
already
told you
told
that
you
this
that
is
this is the
the
uh,
related to the
related to the
absorption.
absorption.
If
If
something will
something will
absorb,
absorb,
then it
then
will
it will
help to
help
the
to the
propagation
propagation
or it
or
will
it will
oppose the
oppose the
propagation.
propagation.
Oppose.
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 If it
If
will
it will
oppose the
oppose the
propagation
propagation
constant,
constant,
then
then
you
you
can
can
say it
say
is
it
like
is like
attenuation,
attenuation,
right?
right?
Correct.
So
So
this
Loss.
this
loss. So
loss.
this
So
is
this is
like
like
attenuation.
attenuation.
Okay,
Okay,
this part
this part
imaginary
imaginary part,
and
and
the
the
real part
real
of
part of
this one is
this one is
propagation
propagation
constant.
constant.
Okay,
Okay,
so you can
so you
remember
can
it
remember it
and you
and
think
you
like
think
that.
like that. Like
This is
this is
absorption
absorption
constant. So
constant. So
absorption will
absorption will
always lead
always
to
lead
the
to the
attenuation.
attenuation.
Okay,
Okay,
and this will
and this
help
will help
to
to the
wave
wave
to
to
travel.
travel.
So we can
So we
write
can
it
write it
as
as a
propagation
propagation
constant.
constant.
Okay.
Okay,
Okay,
this was
this
the
was the
question
question number
four
4
in the
in the
last
So
last
assignment.
assignment.
N naught K naught will only change the angle,
Yes.
but it
Yes.
will not reduce the frequency. Frequency will be same. Correct.
Yeah.
Yeah.
So no loss.
Uh,
Uh,
you
you
cannot
cannot
say
say
the
the
loss
loss
of
of
frequency.
frequency
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 change
change
leads to
leads
the
to the
loss.
loss.
Mm, but if frequency got changed, we lost information, right? Kind of.
Yes.
Yes.
So N naught K naught can cause frequency change or it cannot.
It
It
can
can
see
see
frequency
frequency
never
never
change.
change.
Okay.
Change in
Change
the
in the
wavelength.
wavelength only.
Okay. Okay.
Wavelength change.
Wavelength change.
Frequency
Frequency
never
never
change
change when
when the wave
the
is
wave is
traveling in the
traveling in the
medium.
medium.
This is
This is
the
the
reflection
reflex
in the
in the
reflection law.
reflection
You
law. You can
read it
read
that
it that
frequency never
frequency never
change
change
Okay.
during the
during the
travel.
travel.
Only
Only
change in
change in
wavelength
wavelength,
and you
and you
can
can
say
say
the
the
velocity,
velocity,
right?
right?
All these
All these
parameters change,
parameters change,
but
but
frequency never
frequency never
change.
change.
But uh, if but if okay, we have this relation between frequency and velocity, right? That F equals to
Yeah.
Yeah,
uh,
F equal to C upon lambda.
c upon lambda. Correct. Now, if F is constant, right?
Yeah.
Yeah,
But C is also constant, and if lambda only changes, then frequency has to change, no?
But
but
again,
again,
this
this
is
is you
read
read
the
in the
vacuum.
vacuum.
But
What
Okay.
what
what
if you
if you
read, if
if
you
you
go
go
in the
in the
material,
material,
Okay,
so that
okay.
will
We
not
we
travel
don't
with the
have
speed.
we don't have speed of light. Okay, okay.
E
E
F
F
equal
equal
to
to
V
V
upon
upon
lambda
lambda
then.
then.
Correct, correct. So
So
velocity
velocity
also
also
changes
changes
and
Yeah.
lambda also changes. Okay.
yeah.
Yeah.
Got it?
Got it. Got it. Thank you.
Hmm.
Hmm.
So
So
similarly,
similarly,
if
if
we
we
go to
go
the
to the
next
next
question,
question,
so
so
the
the
dispersion
dispersion
relation
relation
satisfied by
satisfied
the
by the
plane wave
plane wave
solution
solution
to
to
the
the
to the
to the
scalar
scalar
wave
wave
equation is
equation is
given
given
by
by.
hmm.
Hmm.
So
So
now in
now
this
in
question
this
we
question
talk
they
about
talk about
dispersion
dispersion
relation.
relation.
So maybe
So
we
maybe
have
we
some
have
short
some short
discussion on the
discussion on the
dispersion
dispersion
relation
relation
also.
also.
Sir,
So
can
So
you please repeat question once slowly?
the
the
dispersion
dispersion
relation
relation
satisfied by
satisfied
the
by the
plane wave
plane wave
solution
solution
to the
to the
scalar wave
scalar wave
equation is
equation is
given by.
given by.
Simply they are
Simply they are
asking what
asking
is the
what is the
dispersion
dispersion
relation
relation
Plane wave solution
for
to
the
for
the
plane
the
wave
plane wave
solution.
solution.
to scalar
Hmm?
Hmm?
To the
To the
scalar wave
scalar wave
equation
equation
scalar wave equation.
is
Okay,
is
given by.
given by.
okay.
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 So
So
mainly the
mainly the
dispersion
dispersion
relation is
relation is
relation
relation
between
between
omega
omega
and
and
k.
k.
Okay.
Okay.
So
So
if you
if
know,
you know,
then
then
you can
you
tell
can
me.
tell me.
Have you
Have
ever
you ever
heard the
heard the
dispersion relation
dispersion
of
relation of
electron?
electron?
Sir, please discuss.
Uh,
Uh,
so
so like
if
if
you
you
have
have
you
you
seen this
seen
type
this
of
type of
relation,
relation,
h
h
square k
square k
square by
square by
2m.
2m
Yes, sir.
e is equal to.
Okay.
Okay.
So this
So
is
this is
parabolic
parabolic
relation
relation
E
e
into
into
K
k
because E is
because e is
directly
directly
related
related
to
to
omega,
omega,
right?
right?
So
So
in
in
three
three
dimension you
dimension you
just
just
see
see
this
this
type of
type of
Sir, K is what? K is wave number.
yeah, K
yeah,
is wave
k is
number.
wave number.
Okay.
Wave
Wave
number
number
या
या
wave
wave
vector,
vector you can say.
and this
Okay.
And
is
this
the
is the
axis of
axis of
energy.
energy.
So I
So
am
I
just
am just
guessing. If
guessing.
you
If you
know,
know,
then
then
if
if
you do
you
not
do
know,
not know,
just tell
just
me. I
tell
will
me. I
not
will
go
not go
in the
in the
advance.
advance.
Then if
Then if
you
you
this is
this
the
is the
simple
simple
particle in
particle
the
in the
box,
box,
energy of
energy of
particle in the
particle in the
box,
box,
right?
right?
Then
Then
dispersion
dispersion
relation is
relation is
found
found
this one.
this one.
Sorry,
Sorry,
not in
not
the
in the
form.
form.
So
So
this is
this
the
is the
well-known
well-known
relation
relation
for the
for the
electron.
electron.
Then
Then
if
if
balancement and
balancement and
conduction
conduction and
effective
effective
mass
mass
of the
of the
electron
electron
comes into
comes
the
into the
role,
role,
and
and
then
then
we
we
find the
find the
relation
relation
between
between
these
these
all type
all
of
type of
derivation. This
derivation.
is
This
all
is all
contains
contains
matter
matter physics
study.
study.
But this
But
is a
this is a
simple
simple
form.
form.
This is
This is
parabolic.
parabolic.
Similarly, if
Similarly,
I
if I
ask you,
ask you,
if you
if you
write
write
this
this
relation for
relation
the
for the
photon,
photon,
how will
how
you
will
write?
you write?
So
So
just
just
remember that
remember that the
ele-
the
dispersion
dispersion
relation for
relation
the
for the
electron
electron
is
is
parabolic,
parabolic,
but for
but
the
for the
photon it
photon it
is
is
linear
linear
relation.
relation.
So
So
linear
linear
relation is
relation is
omega is
omega
equal
is
to
equal to
c
c
into
into
k.
k.
So
So
this
this
goes
goes
like this.
like this one.
Okay,
Okay,
this is
this
the
is the
I
I
want to
want to just
connect.
connect.
If you
If you
remember
remember
this
this
one,
one,
you
you
can
can
remember
remember
this.
this.
If
If
I
I
will
will
like
like
just
just
uh, little
little
bit
bit
before
before
you
you
talk
talked
about
about
grating,
grating,
right?
right? So in the gating, this is the periodicity of refractive index, right? Like this is N1, this is N1, this is N1, and in between N2, N2, like that. Okay, so this is periodicity of things here, and similarly in the matter, if you see this in the crystal structure, some arrangement are there, right? Atoms arrangement. You heard about BCC structure, FCC structure, right? So there are some certain arrangement of atoms which create the potential, okay, for the electron moving inside the crystal. So from this relation it comes from this one, and also due to periodicity, some billion zone calculation are going on. So this is comes like this is pi by a. If the periodicity of a, then this is pi by a. If a increase, this will decrease. Okay, so the confinement will increase. Similarly, if you say then this Brilliant zone calculation, Koenig model all comes into a play, then you have seen this type of band structure, right? Have you seen this type of band gap structure? This is all related, explained by this free electron theory only. Or I am going little bit advanced. Just tell me.
Yes, sir.
Yeah, yeah. Okay. So similarly, in the photonics, if you just create some structure like grating, you will find some pi by a here. Similarly, pi by 2a here, pi by minus pi by a, and then you will find here photonic band gap. Similarly, at the edge of this one, this will little bit bend. There difference between this structure is this is parabola here, and here this will be the straight line, and then only just bend. I think this will come in the lectures later, and all the calculation will be done how this bend here and here, not here. Okay, so this is the mainly the relation of dispersion relation for the photon. Okay, so this is a simple question answer that omega is equal to c into k, and c is you can relate it as a mu, because mu is the velocity of wave in this one. Say you can write like this. So this is the dispersion relation for photon. I compare it with this one, so that you can just remember this is parabola and this is a straight line in photon.
So CK is for vacuum.
Yes, CK is for vacuum.
Okay.
Like here again, I little bit explain thing. Like this is called as light line. Okay, and if some material has some frequency than this wavelength, then it goes to little bit lower or little bit higher, depending on this v, because the slope is the v. Okay, then you can say this the like we have interface of two things, like one is gold, and on top of this is silver. Okay, so for gold this is omega p is different, silver is omega p is different. Okay, and this velocity is also different in these two materials. So I think this is let's consider this is gold and this is silver. So the only frequency comes in this region can guide in the interface of this material. Okay, this is all about this this special question or any theory.
So this, okay, basically this is concept of waveguide, is it?
Yes, yes,
Okay, okay.
yeah. So the concept is photonic uh, uh, photonic crystal also, like this is our light line which is corresponding to omega is equal to c k. Okay, and this is k and this is omega. So if k मान लिया k is value is there here. Okay, so all the in this region whatever omega exists, this is called guided mode. Okay, so guided mode energy which we can say with the propagation constant beta. Okay, this beta should not be greater than this omega, then only we can say the guided mode. Okay, like uh, if you know the bound state. So in bound state, this is the potential, and this is the let's say energy of particle which is moving around this potential. Okay, so if energy is greater than this potential, then you can say this can move freely anywhere, right? And if you have the energy less than this potential, maybe in this region, then it can be caught by this potential, and this is called the bound mode. Similarly, in the photonics, you can say these energies can be connected with this beta, which is the propagation constant, and this potential B can be related with this refractive index n. Okay, so if beta is less than n into k naught, then it is guided mode. All this is the guided mode theory comes when this discussion starts. Okay, and the photonic crystal, why this is special? Because in photonic crystal, guides are not modes are not guided. These are somewhere here in this region. Okay, and this is the in z direction. And z direction there is some finite thickness only. Even this is mode is found in this region. Guided mode found in the above light line. I think this is little more advanced. It comes in the third or fourth week, I think. I will not go into the detail of this one. So for now, you can just remember that the dispersion for the photon omega is equal to c k. Okay. And the next question, sixth one, is from the section diffraction limit. So what is the diffraction limit? So always remember that diffraction limit comes the from the wavelength. Okay. So always lambda by 2 is the diffraction limit. This is all these diffraction limit are concept is very important when we go to the lithography. You know the photolithography, because this is discussed in the diffraction one chapter. So what we did in the lithography, we have some things in the substrate plane, and we want to pattern of some definite size. Okay, and we use, since this is photolithography, we use this photon or wave. Basically, mostly used. It is also known as UV lithography. Okay, so we use UV light. UV light is around 300 nanometer wavelength. Then, how much structure we can get? Because if light is, see, light is diffracted from some small aperture, right? So if this aperture will less than lambda by 2, then actually this lambda by 2 is known as diffraction limit. But this is again in vacuum only. If you go for in some material, so that diffractive index of that material will be n, then you can say this diffraction limit is lambda by 2n. Okay, so like in what is the use of in this lithography of this diffraction limit is that, mm, the how small you can write the structure. Like we need 300 nanometer small structure. Okay, and we are exciting with the UV light of 600 or see, not UV light, light greater than 600 nanometer. So this structure cannot be obtained from this wavelength, because this structure is less than lambda by 2. So this is the diffraction limit. So minimum in the lithography system, minimum feature we can find of the size greater than lambda by 2. Less than lambda by 2, we cannot find. Like UV lithography, if we use 300 nanometer wavelength to excite for the as a lithography source, then the minimum feature we can write 300 divided by 2 is equal to, because this is traveling in the air. So refractive index, we in air we are considering 1. So 300 by 2, 150 nanometer. So this wavelength in lithography source, you can only form 150 nanometer at the base of your instrument. Okay, and the in the lithography, what we did, we take the source, then some focusing element to focus this wave, and then there is some numerical aperture of this source also. Okay, so this system is also depend on this numerical aperture, this focusing system, and this wavelength due to diffraction limit. On wavelength depend due to diffraction limit. Other dependent parameter is focal alignment, focus alignment you can say, and third is numerical aperture. If all are perfect in this region, then you can find only 150 nanometer with this 300 nanometer wavelength. So this is sort of discussion done in the diffraction uh, in the diffraction limit section in the lecture. So one simple question in the assignment is depend on this one key, what is the diffraction limit. So this is lambda by 2n is the diffraction limit. Okay. Similarly, seventh question in the last assignment, they give which of the following factor influence the resolution in the optical lithography system. So as I said that this is the numerical aperture, this is the focusing optics, all these things. Okay. So the parameter which will affect the resolution of this lithography will be the wavelength due to diffraction limit, according to diffraction limit you can say, and second one will be numerical aperture, NA, and focusing optics. Okay. Third parameter will depend empirical constant, capturing process related factor. You can see the more about this concept in the video. So empirical constant K1. I am not sure about this thing, but this is also a factor. Empirical constant K1. Okay. So this was the seventh question in the last assignment, and I think this you can
So
next question. Huh.
In previous question, all three will affect the resolution.
Yeah, all three will
Okay.
affect. Actually, I'm not very sure about this empirical constant, so I cannot explain this much. But I will, if you ask, I will explain in the next
Yeah.
session.
Thank you, sir.
Okay. So the next question was the 532 nanometer lambda hai. Then what is the E? Simply you can calculate. I have been giving you the formula 1240 divided by 532. You will calculate
2.33.
yeah 2.33 is the right answer. Okay. Similarly, one more simple question like 1.98 eV is the energy. Then what is the lambda in micrometer only? Again, you can just this is EV. So 1240 upon 1.98. So this is around 6 or something. This is around 6, na? This is 12. This is you can consider as 2, right?
626.
626. So 626
Nanometer.
this is nanometer. So if you have been asked in micrometer, then convert it.
0.626 micron.
Okay. Now one more question to discuss. Not one. There is 8 more. I will go too fast little bit. So 10th question is just we have one electron volt momentum of electron. Okay. Momentum of one electron volt electron is the momentum of photon of the same energy. Like this is the electron energy. Okay. This is the photon energy. Same energy. Which momentum is the large? Or this momentum will be equal for the electron and photon both. Can you think about that? Or how will you approach?
Sir, can you explain question once more? I didn't understand.
Like this is the energy of electron 1 ev. Okay, this is for electron, and photon energy is also 1 ev. What about momentum? Momentum of photon or momentum of electron is equal, greater than, or less. Or you can say either it will be equal or it will be different. Different, then which momentum is larger, photon or electron?
Can we calculate
Um,
momentum?
Yeah, you can calculate. See,
So for photon, it will be uh, momentum relation h nu na. What was that? B equal to h by lambda, right? Momentum.
huh?
P equal to h by lambda.
Huh. E equal to h by lambda, and E is equal to hc upon lambda.
Yeah.
Okay. So if you convert it with this one, hc h upon lambda is equal to E by c. P equal to E by c. Right. This is for photon. Similarly, for electron, you can write P is equal to m into v. Right. This is for particle. So how can you calculate V? V is from the kinetic energy. So E is equal to 1 by 2 mv square. So V is equal to 2E by m root. Right.
Right.
So P is equal to m under root 2E by m. So similarly you can write P is equal to under root 2 me. E is same for both. Okay. So M is the of the order of 10 power minus 31. Right. 31 or 77. Mass of electron is 31. And E and C is order of minus 8. And because E is same for both. Okay. The resultant answer will be electron momentum. The momentum of one EV electron is greater than momentum of photon always. Doubt? Hmm?
So just momentum, if we calculate from the two expressions, we will get the momentum of electron is more, correct? Because of mass.
Yes.
Photon is massless.
Yes.
Okay.
And also you can think about that like if mass of electron is see electron mass is this m. So I would like to denote as m star. This will not be the exact mass.
Effective mass.
This will be the effective mass. Okay. So effective mass depend on velocity. Okay.
Hmm.
So if you calculate the wavelength of this electron at the same energy, then you will find that the velocity of electron will be in the relativistic region. Okay.
But effective mass, how will you find?
Uh, so this is around 1 upon Dever square E over Dever K square. Have you seen this formula?
I was thinking from Einstein relation, but maybe I can be wrong. I was thinking from E equal to mc square.
Equal to mc square. This is that's why I'm saying that is the relativistic reason.
Okay. Okay.
So that momentum will always higher than
Okay.
photon.
So for this question, we are considering effective mass or static mass of.
You can consider static mass.
Okay.
Okay.
But
Because there is not the much information about this K or all these things
okay.
to
Okay.
calculate the right.
Okay. First order calculation maybe. Okay.
Yeah. Okay. This is the thus number 10. Number 11. Simple question was 2000 centimeter inverse is the wave number. What is the wavelength corresponding this wave number? Simply you can write K. See, this is the centimeter inverse, right? So Babe number is simply k upon 1 by lambda. When we talk about the Babe vector, then it is comes 2 pi by lambda. But if someone is talking about only wave number, then you can simply consider 1 upon lambda. See, simply this is a, if this is in centimeter, then k is in centimeter inverse, right? So you can just calculate easily. 1 upon 2000 is equal to 10 to power minus 3 into 0.5 centimeter, right? So if you calculate this lambda in nanometer, then 1 2 3 4 minus 9 nanometer. Understood or not? Simply you have to, if you want to calculate Babe number to Babe length, just do it 1 by lambda. If not any query, I go to 12. So this is consider a glass slab of thickness of 100 micrometer, okay, or light wave is of 500 nanometer, lambda is equal to, then which of the following statement is true? First statement is the glass slab will break. Definitely not. Or will break. Don't know. No light comes out of the glass slab. Is it possible? The frequency of the light coming out of slab changes, and the frequency of the light coming out of slab is constant. So what do you think, which answer is correct?
Frequency can't change, right?
Yeah, frequency can't change. So this is the accepted answer.
Can you repeat the options once?
The glass slab will break.
Okay.
This is definitely not. And no light comes out of the glass slab.
No light. Okay.
And the frequency of light coming out of the slab changes. So frequency will not change. This is our fingertip point. So definitely. So in 13, simple question. The beam of light at lambda is equal to 532, okay, is incident on air glass interface. So this is air and this is glass on interface from the air side. Okay, from the air side. What is the wavelength of light in glass of refractive index 1.5? This is given 1.9. So what will be the lambda dash here? So I told you lambda is equal to lambda by n, right? This will be 532 upon 1.5. It will be around 15 tiya 45, means 355. Okay. Understood this question or any doubt? Simple question was this, right? Now one advanced question is coming. Not very advanced. Just the concept thing. This is given that Ex comma T is denoted by tan cos 2 pi 2 into 10 to power 6 x minus 4 into 10 to power 8 t volt per meter. This is the unit of this E. Then this is the common information for next 2 3 question. So question is What is the
amplitude?
amplitude?
If you
If you
remember
remember
the
the
earlier
earlier
I
I
told,
told,
then you
then you
can
can
very
very
simply
simply you can
told
10.
10.
10.
Right
Right
answer.
answer.
So
So
how will
how
you
will you
approach?
approach? Like
Simply you
simply you
just
just
remember
remember
this
this
E
E
naught,
naught,
cos or
cos or
sine you
sine
can
you
write
can write
anything here.
anything here,
Just the
just the
change of
change of
phase,
phase,
initial
initial
phase.
phase.
Okay.
Okay.
Cos
Cos
2
2
pi
pi
and
and
kx
kx
minus.
minus.
If you
If
write
you write this
2 pi
2 pi
here,
here,
okay,
okay,
you can
you
write
can
here
write
f.
here f.
This is for
F is for
frequency.
frequency.
Omega is
Omega
angular
is angular
frequency.
frequency.
Omega is equal
Omega
to
is
2
equal
pi
to 2
f,
pi
right?
f, right?
Into t.
Into t.
Okay.
Okay.
So
So
this is the
this is the
amplitude,
amplitude,
and
and
this
this
f
curve f
we can
we can
in
in
next
next question
have
we have
what is the
what is
wave.
the wavelength.
See, 2
See,
pi
2
is
pi is
already
already there.
okay.
Okay.
So
So
now this
now
is
this
only
is
wave
only wave
number.
number.
So wave
So
number
wave
k
number
will be
k
1
will be 1
upon
upon
lambda,
lambda,
right?
right?
So
So
according to
according
this
to this
equation,
equation,
this is our
this is
k
our
or
k
not?
or not?
This is our
This is
k,
our k,
right?
right?
Yes.
So
So
just
just
you can
you can
find
find
lambda is
lambda
equal
is
to
equal to
1
1
upon 2
upon
into
2
10 to
into
the
10
power
to the power
6
6
equal to
equal to
0.5
0.5
into 10 to
into
the
10
power
to the
minus
power
6
minus 6
is equal to
equal to
500
500
nanometer,
nanometer,
right?
right?
Similarly,
Similarly,
question
question
16,
16,
they want
they
to
want
ask
to
the
ask the
time
time
period.
period.
How will
How
you
will you
calculate?
calculate?
T is equal to
T is
what?
equal to what?
1 by F.
1 by f,
1 by
right?
f, right?
So f you
So
can
f you can
calculate from
calculate from here.
1 by
1
4
by
into 10
4
to the
into
power
10 to the power
8.
8.
Okay.
Okay.
So this
So
is
this is
0.25
0.25
into 10 to
into
the
10
power
to the power
minus 8.
minus 8.
So you can
So you
write
can write
2
2
5
5
into 10 to
into
the
10
power
to the power
10
10
minus 10,
minus 10,
2
2
5 double
5
0
double 0
into 10 to
into
the power
10 to the power
minus 12.
minus 12.
So
So
minus 12
minus
is
12 is
picosecond,
picosecond,
right?
right?
Similarly,
Similarly, in
question
question
17,
17,
what is the
what is the
velocity
velocity
in meter
in
per
meter
second?
per second?
How will you
How will
find?
you find?
V equals to F lambda.
Eh?
Eh?
V is
V
equal
is
to
equal to
f
f
lambda.
lambda.
Yeah,
Yeah,
good.
good.
So
So
lambda is
lambda
5.
is 500.
This is in
This is in
nanometer.
nanometer.
Okay?
Okay.
And
And
f
f
is
is
4 into
4
10 to
into
the
10
power
to the
8
power 8
second.
second.
Sorry, per
Sorry, per
second.
second.
So
So
20
20
double
double
0
zero
into 10 to
into
the
10
power
to the power
8
8
nanometer
nanometer
per
per
second.
second.
We want to
We want to
convert in
convert
meter
in
per
meter per
second.
second.
So
So
200
200
into 10
into
to the
10
power
to the power
9
9
nanometer
nanometer
per
per
second is equal
second is
to
equal to
200 meter
200
per
meter per
second.
second.
Okay,
Okay.
this will go to the in this
In
one
this
to
one to
convert
convert
meter.
meter.
And here is the
And
last
here is the
question
last question
for
for
today's
today's
assignment.
assignment.
The
The
electric field
electric field
intensity vector
intensity
is
vector
given
is given
again E
again
r
E
comma
r
t
comma
is equal
t is
to
equal to
10.
10.
See here it
See
is
here
given
it is
sine
given sine
3000
3000
t
t
plus
plus
0.03
0.03
x
x
plus
plus
20
20
ay.
ay.
Okay.
Okay. So we have to find the phase velocity. So phase velocity just I told you omega by k. Okay. So again you will calculate this is our omega, which is our omega. This one or this one? This is omega because this is multiplied by t,
3000
3000, and this is our k,
kx.
right? Okay. So this is 3000 upon 0.03. So 2. So this will be 10, but in which form? Omega is second. Sorry. Will not cut it, but 2 will increase. 2, 1, 2, 3, 4, 5. So this will be 3 into 10 to power 5. Okay. Answer is like in the assignment, this is given, fill in the blanks, multiply by 10 to power 5 meter per second. So answer will be 1. Okay. Got it? So these are tutorial questions for today. If you have any doubt, you can ask me again. You have 5 minutes.
Sir, quick question. For studying this course,
Okay.
how much of this quantum, this one, electronics we need to know? Like, is it a lot of depth we need to know?
No. I don't think.
Quantum physics.
In quantum physics, if you know this operator things, I think in the last week or second last week uh, videos, you will find like little bit this quantization point. What is quantization, that you should know,
Okay.
and how
Like,
to quantize.
background wise, what should we know, like, for this course?
Background wise, if you have a basic quantum physics knowledge, like uh, we say first part of quantum, like particle in the box and
Okay.
type of solution in the box. If you that much you know, you will understand the concept here also.
Okay.
Actually, here I just want to compare because I think you have already knowledge about quantum electronics. So this is all point of view of electron
Hmm.
or photon. Sorry, electron or particle. Okay. Here we talk about like just uh, if I ask question in the different way, like you know already the particle in the box. If we confine particle in the box, what is the energy?
Hmm.
And again I will ask you, what if we confine the particle in the box, we put out the particle and put the photon there, what will
Okay.
be the effect?
Okay. Understood. Understood.
Uh, so here the see, there is the quantization of energy. Okay. Here energy converts into the wavelength. Okay. So quantization of wavelength will be there, quantization of see, energy is only depend on lambda here, and wave function, there is psi is the wave function we consider as a scalar.
Hmm. Hmm.
But here there are two types of wave function, E and H. So here will be some vector calculation will be there, definitely. That is the little bit different I can tell you for now. And if you
So,
want to
hmm.
give me some feedback,
So this lectures that are there in the course, like week one, week two,
okay,
so that is sufficient, or do we need to do some extra study to do well in this course?
that will be enough
Okay. Okay.
mostly.
Okay.
Or if I feel something is missing, some small concept or it should revise, then I will also include in my session. Or you can feedback me that I want to learn this thing because I did not understand this topic.
Okay.
Then can also prepare according to that.
Okay. Sir, one feedback.
Yeah.
So next time, like, it will be better if you have like a snapshot of the question on this screen.
Okay, okay, okay.
So because you are trying to recite the question, we cannot write down, and
Okay, okay.
so that will be helpful for you also, us also. Maybe.
Surely
Yeah.
I will do in the next session.
That will be good, sir.
Okay.
Otherwise, yeah, thank you so much for your time. Yeah.
Thank you. Any other query?
Sir, one
Yeah,
doubt
yeah,
is there.
yeah.
In the section perpendicular reflection, how do we calculate the components of wave vector, like parallel and perpendicular, like components?
Okay. So see, very simple example I will do give. So this is our plane. This is z equal to 0 plane. Okay, and light is coming from this side, and in this medium something like this. This is medium 1 epsilon 1. This is epsilon 2. So you are saying that how we recognize what is the perpendicular and what is the parallel wave vector, right? So this is
Yes.
the incident plane. You can see if z equal to 0 is this one, and also like generally we give the coordinate x, y, and z. Or if z is this one, then according to thumb rule, this will be x and this will be y. Do you know this thing? How we sorry, what it is called? How we assign the, like, this is the general coordinate arrow, right? So if this is x, this is y, then this is definitely z, right? Similarly, it rotates
Yeah,
clockwise.
like crosswise, both said.
Yeah. So if I consider this plane is z equal to 0, so this is along this line is z equal to 0. Okay. So right hand thumb rule you can apply from x to y. If you move your this thumb should be in the direction of z. Okay. So according to that, you will find x will be this and y will be this. Okay. So if I convert it like this is k vector, so this will be our, according to this one, this will be kz, right? Z equal to 0, yeah, minus kz. And you can break it. This is k x, and the perpendicular direction will be ky. Okay. So the wave vector in the uh, plane of this coming wave, what will be kx and kz, right? This will be our k parallel, and our k perpendicular will be ky by k. Do you understand now?
Yes, sir. Yes, sir.
Any other doubt? If you don't have any doubt, then we should